Hi, everybody. Welcome to another Chats with 𝐒𝐤𝐳. I hope you're safe and well. Today, I'm delighted to be joined by Martin Deetz, who's the technical laureate at Dupont Water Solutions. And today, we are going to be talking about oligonucleotides purification. And Martin was listening to me very carefully when I said that, because I was just talking about how I was trouble saying it. So, Martin, good afternoon or good morning. How are you?
Good morning. Thanks for having me. I'm doing great.
Fantastic. And where are you calling in from this morning?
I'm near Philadelphia, Pennsylvania in the US.
Hence, I've got the Eagles shirt out. Although I found out that Martin's actually a Browns fan, so I need to.
You have an orange shirt, though. That works.
That's true. Although this is for the Dolphins, but it counts as well for the Browns. Exactly. All right. Well, brilliant. So, Martin, let's talk about oligonucleotide purification. But before we do that, can you give people a very quick overview of Dupont Water Solutions and also your own role there?
Sure. So, as I mentioned, I'm a technical laureate in that group, which is one of the lead scientists for the business. And, Dupont Water Solutions, from the name implies, is largely focused on water and water purification technologies from industrial water to microelectronics and desalination, wastewater, all that sort of stuff. But there's also quite a fair amount of our business also focused on what we call specialty, life sciences and specialties, which includes a lot of non-water applications. So sweeteners and catalysis and mining and bioprocessing. And that's what we're focused on here to talk about, is bioprocessing and some of our materials that go into that.
Fantastic. Well, let's talk about oligonucleotides then. So first basic question is, what are oligonucleotides?
Sure. So in short, oligonucleotides are short sequences of nucleic acids. In fact, they even have a short nickname, and we call them oligos. So to save you from trying to pronounce that, we can just call them oligos from now on. So they're typically DNA or RNA-based molecule, typically range from about 10 to 150 nucleotides long. They're used for research, diagnostics, and therapeutic applications. So these are small, right? And if we think about mRNA, we've heard about the vaccines, those are much longer nucleotides. So those are maybe 5,000 nucleotides long. So we're really talking about short sequences. So if we step back for a moment and think about why these are so interesting, if you remember back to maybe high school biology, DNA is made up of 4 bases. So even short sequences of DNA are very unique. So for example, a 25 mer or 25 length of DNA has over 4 quadrillion possible sequences. So this level of uniqueness in such a small package makes them great tools for research and diagnostic applications to very selectively pair with its counter sequence. So in any case, if I get back to high school biology again, so DNA is transcribed into RNA, and then RNA is transcribed into proteins. So in many diseases, the proteins are the things that cause problems. So when these are used for therapeutics, these oligonucleotides function to disrupt the process of converting the DNA genes into protein and subsequently treat the disease. So this is how most of today's therapeutics work, through gene silencing. So there are about 15 FDA-approved oligos, with over half of them in the last approved in the last 4 years. So this technology is really trending right now. And then add that on to research tools like CRISPR and so forth, and this area is definitely very hot right now.
Right. And what is oligonucleotide purification, and why is it important?
Yeah, I'll go through that. First, we got to talk about purification. What's being purified from what? So if we think about how oligos are made, they're made from a synthetic process whereby a full sequence is built on a solid support by iterative chemical transformations, building up one at a time. So this is usually done on like an automated synthesizer. And so once that oligo sequence is done and built up on that solid support, it's deprotected and cleaved off that support. So this step releases the target sequence along with any failure sequences from the chemistry inefficiencies, as well as byproducts from the step. So at the end of the day, the goal is to get the target oligonucleotide fully deprotected and ready for the application. And almost universally, chromatography is used to do that purification. So with oligos, both the ionic nature and hydrophobicity of the molecule can be leveraged to separate the targets from impurities. And along the way, there are some other interesting things like on-resin detritylation that can be used to combine steps and make this complex purification process quite simple. And we'll talk about that in a lot more detail in our upcoming webinar.
All right, well, we'll talk about the webinar at the end, but what are the main oligonucleotide purification challenges then in process development and production? And also, how are polymeric resins, how can they solve oligonucleotide purification challenges?
Sure. So for research oligos, we talked both about research and the therapeutics now. So for research oligos, absolute purity is typically less important. And the goal is to have a fast, convenient, generally applicable method to get the oligo ready for the next experiment, like CRISPR editing, for instance.
Right.
And whereas for therapeutics, the challenge is very different. In this case, you really want high purity, high throughput, lot-to-lot consistency in production is the key. So the reverse phase polymeric resins can deliver both, right? For quick and fast, or high purity, high throughput. And these resins can deliver both, and those that tune into the webinar will hear about all the topics we discuss. We have purification strategies for the trityl on and trityl off oligos to remove failure sequences and the synthesis byproducts. We even have a section on tips for generating a new method for oligo separation. In other words, how to get started, with your possible 4 quadrillion sequences, how to get started in developing a method. And then finally, a new, really optimized way for cartridge purification and on-resin detritylation that is really fast and simple.
Right. So you were talking about the webinar and then what you're going to do. So let's tell viewers when the webinar actually is. And the webinar is running on September the 22nd at 10 a.m. Eastern time, 3 p.m. UK and 4 p.m. CET. So whether in Europe or the States, you can actually catch not just Martin, who is presenting, but a couple of his colleagues as well, all of who I've actually interviewed live at shows, interestingly enough. So we'll put the details there. So if people want to know more, obviously they can sign up for the webinar, Martin. But if people can't make the webinar, where else can they get more information?
Sure. The webinar will be available on demand. We, in our Water Solutions website, we have webinars on all sorts of topics, right? If you want to run, know how to run a nuclear power plant with the water purification or others, you can go there as well. So all of these are available on demand. So, we've been really busy in the lab on these topics here with oligonucleotides. We really love folks to join in, hear how these resins can help with their own studies. We'd also love to hear from others on what studies would be important for us to do next. We're always trying to get the most relevant content to share that people can take and convert right to their own work as quickly as possible.
Brilliant. Well, look, Martin, thank you for that. And you know what, even in that short time, I've learned more about oligonucleotides than I did before we started this conversation. So thank you for sharing that information with me and the viewers. There you go, viewers. If you'd like to know more about oligonucleotide purification, then check out the webinar, which is coming out on September the 22nd, which will feature Martin and his colleagues, who will talk about the various challenges and solutions around oligo purification. And his colleagues, I must mention as well, so I'll get in trouble. So they're right in front of me and I haven't even mentioned who they are, which is also Sophie Corbet and Daryl Gisch, who will be presenting with Martin in that webinar. And actually, Martin and Daryl actually presented a poster with me in the past at, was it Tides, I think? USA.
It was Tides in the spring, right?
Tides USA that you actually did a presentation. So I will put the links actually to those poster presentations that Martin did and Daryl did with me at Tides, so you can have a look at them as well as sort of a preview to what's coming up in the webinar as well, see what they talk about there. So Martin, it's lovely to see you. Obviously, the Browns have won their first game of the season, so here's hoping that continues and they have a great NFL season, as well as, well, they don't have a hockey team, do they? But the NBA season will be kicking off soon as well, so hopefully that goes well for you as well. But look, it's lovely to see you. Thank you very much. Good luck with the webinar. And viewers, if you'd like to know more, the link for the webinar is above the video, but also the link to the Dupont Water Solutions website will be there as well, so you can get other information on the on-demand videos that Martin mentioned, but also lots of other information they've got on there. And if you've got any questions or comments based on what Martin said during the interview, feel free to put them in the comments below, and also message Martin. He's on LinkedIn as well. So Martin, thanks once again, and viewers, thank you for watching, and until next time, stay well and stay safe. Bye-bye.
Bye-bye.